Good evening, everyone. My name is David Harris, and I'm the Director of Business Development for vecor. vecor is a startup company. We're expecting to realize revenue this year, so we're a fairly advanced startup company. And our business is comprehensive recycling of the solid waste from coal power stations. So what John mentioned in his last presentation, the brick is composed partly of fly ash, and that's what we do is we solve a fly ash landfill problem. So I'd like to thank Charles for inviting us to present today, and thank David as well from Clean Tuesdays for his vision and organizing what seems to be a very exciting program. vecor utilizes the solid waste from power stations, and what we do is we convert that solid waste into a clay replacement, into industrial minerals, and into resource-efficient building materials. The problem we address is a global problem, and it's solid waste from fly ash landfill. Basically, when a coal power station burns coal, the material that isn't actually burned in the process flies up. A large portion of it flies up into the flue, into the chimney, and then it's collected by precipitators, and that's called fly ash because it flies up. And a typical power station dumps between 300,000 to 1 million tons of that waste every year. And with 2,000 or more than 2,000 power stations globally, it's really a large landfill problem. In the US, they're landfilling over 100 million tons a year. In China, they're landfilling somewhere between 300 million and 500 million tons a year, and the list goes on for most developed countries. And coal power isn't going away anytime soon. It's expected to increase. In fact, the coal power generation is expected to increase about 40% in terms of total generating capacity in the next 20 years. Currently, the cement industry is the only industry that's actually utilizing fly ash in any real volume. They're able to utilize the smallest particles, about 25% of total fly ash produced. They use that as a cement additive because it's very cementitious. There are some other uses for fly ash, but they're generally very low quality uses in road fill or filling in old mine shafts, or even some bricks and blocks. They're low quality. They're not very durable. And there's not really any wide-scale market opportunity for those to utilize large volumes of ash because the cost of transportation for those products are just not viable. The margins are too thin. So of course the coal power industry has a lot of cost associated with disposal, maintenance of the fly ash landfill sites. They're restricting growth of coal power stations in mainland China. There is a directive that came down that no coal power station can receive a license unless it can demonstrate 100% utilization of fly ash, and that just came in last year. So it's restricting their ability to go out and gain and maintain market share. And of course there's negative PR associated with it. This is a picture from a fly ash lagoon that collapsed in Tennessee in the United States in 2008 and dumped about 5 million gallons of fly ash waste onto a small town. The public, of course, is concerned about environmental degradation, and fly ash does have some toxic or some toxins, heavy metals, etc., that are a concern for health. So vecor approaches this as an opportunity, and the opportunity is to recycle this waste-grade material that goes into landfill and to produce high-value products. So this gives you an overview of our approach to solving this landfill problem, this solid waste problem, and really, instead of just having the cement industry or some low-value applications utilizing the fly ash, our vision is to broaden the number of industries that can utilize that fly ash profitably. And we think that's important, profitably, because there was a question for John in the last presentation: what type of premium would you be willing to pay in order to utilize green technologies in your buildings? And we believe that in order for a green technology to truly be successful, it has to be viable in the market. There has to be a pull from the market that isn't just green, and that's particularly true in emerging markets such as China, where it's extremely price sensitive. So our business is to be a solution for the coal power stations, providing them with utilization and elimination of their waste. In fact, in most developed markets, we're actually offered money to take that way, so that's also a revenue stream for the company. vecor then locates a processing facility directly beside the fly ash dam or the coal power station, because we can use the waste that comes from the landfill site as well. And we set up a processing facility beside that site, and we produce a number of products. And the most important and the initial product that we're producing is vecor clay, which is effectively a clay replacement. We utilize that material to produce a range of high-performance building products, including ceramic tiles, cladding for the exterior of buildings, sintered bricks and blocks, which is very different from non-sintered fly ash bricks and blocks in terms of performance and durability, pavers, engineered sands, aggregates, and refractory materials. And we do have some product here. This is a tile that is produced of about 80% fly ash. And on top of it, you can certainly come up and see later, there are two types of aggregates, two types of densities in aggregates, sintered aggregates that can be used for mixing with cement and used in concrete for civil engineering structures or buildings. So our key, I won't go too much into the details of the company. I was asked to focus on the kind of the innovation and the technology, but we are quite an experienced group of entrepreneurs and researchers. I'm joined here today by Dr. Eric Severin, who is our Director of Technologies, Mineral Technologies. And we also have a prestigious group of advisors and seed angel investors, as well as strategic partners. The core IP for the company comes from the University of New South Wales in Australia. I will tell you a little bit about Alex Koso, who's the CEO of the company. Alex is a Hungarian refugee who made his way to Australia. He worked in the building trades, as many refugees do, and built up his own business in Australia quite successfully, listed a company in Australia, IPO'd, and then after a series of other fairly successful ventures, he ended up in China looking at opportunities in China. And being from a building materials background, he looked at the buildings in China, and he realized, and he saw that, even after a few months of them being built, the quality, the actual appearance of the buildings was very, very poor. So he looked into the paint, and he had a background in paint, so he looked into the quality of the paint and tried to identify perhaps a low-cost paint that he could sell into China. He looked more closely at the problem, and he saw that it was a render problem. It was actually the concrete and the render that was really low grade. There's a shortage of sand in China, which is surprising, but it's river sand, good quality river sand. So what they do is they just break up rocks, granite, and mix it up, and that becomes the render, the sands that they're using. So he tried to find a way of manufacturing sand in order to help solve this problem. He went and found a patent at the University of New South Wales for sintering fly ash, and then took that and prototyped some sands and some aggregates and some other materials very successfully technically, but the energy costs of firing those sands weren't able to compete with just crushing rocks. So looked at products that would actually be able to compete on an energy cost standpoint, and ceramic tiles ended up being a product that stacked up very well financially and technically. So that's kind of the brief history of how we got to ceramic tiles as our initial product. Since then, we have prototyped a very broad range of products, like I mentioned, and the sands, in fact, we've developed a way to fire those sands so that they are cost competitive, so that becomes one of the products that we're able to broaden the uptake with, is engineered sands. Core values of the company are sustainability, performance, and profitability. We ran an industrial scale production run in Italy. We custom designed our own hardware and ran a production facility in Italy. We asked the engineering firm Arab to come and kind of verify the technical viability of what we'd achieved, and also to provide an environmental life cycle analysis. And what they found was that we use 82% less water than a standard ceramic tile manufacturing line. We use 80% less virgin materials because of the recycled content, the fly ash content. We use 40% less energy and 28% less thermal energy. And all of these things add up to, of course, environmental advantages, but cost savings as well. So that's why we're able to compete not only on green credentials, but on profitability. Performance and profitability, I compare vecor tiles with clay tiles. and with porcelain tiles, and then the vecor tiles in the right-hand column. So in this column here, you can see the European standards. Here are high-quality porcelain tiles from Italy or another advanced market like Spain, and then the vecor tiles. Three main performance criteria that you look at when you're talking about tile performance: water absorption, modulus of rupture, and abrasion resistance, the scratch resistance. Modulus of rupture is the bending strength. And you can see that vecor stacks up very well against both the European standard and the world's best porcelain tiles on all three of those. In terms of cost competitiveness, because of our resource efficiency and our energy savings, in developed markets, we project that we have almost double the operating margin in markets such as China, where we're actually building and operating our first manufacturing facility this year. We're looking at an improvement of about 25% on the operating margin. This starts to get into our business plan and our vision and our rollout. We have a large number of products in prototype stage, and we move them through from concept to prototype to industrial scale testing, showcase, which is where we are with the Chinese business right now. We're showcasing the tile business with a commercial venture in China, and then global rollout, which is the actual expansion of the business into other markets. We just completed a $5 million equity fundraising round last year in November, and we're currently in a fundraising round of $50 million, which is going to allow us to build our first tile production lines and our first separation facility, and then position us to scale up and provide this solution to power industry and building materials manufacturers globally. I know that we've got a lot of speakers tonight, so I don't want to take too much time, but I'd be happy to answer a few questions if anyone has any. Yes, please.
So as you mentioned, fly ash is basically everything that doesn't burn in coal, which includes heavy metals, includes a chunk of compounds which have adverse effects on health. And to my knowledge, there hasn't been any testing as far as human interaction with fly ash, cement, or brick, or ceramic. So is your product coming into contact with people? Do you expect any effects from people being near your product?
Thank you for the question. I'll clarify. Fly ash isn't everything that isn't burned. It's probably about 70% of what isn't burned. So that's one distinction. But you're right. Fly ash does have heavy metals as a component. This building has probably around 25 to 30% fly ash in the concrete that's actually built this building. So in terms of exposure on that level, certainly there are industry standards. The way that we approach that is when we're looking at fly ash sources, we survey different power stations and different landfill sites, and we run very, very thorough tests to identify the radiation levels, the heavy metal content of the product. So the radiation we filter out, and we don't use anything that has high radiation, and it's about 80 or 90% of sources that we've identified are absolutely suitable. On the heavy metal side, the difference between our product and an unsintered product, a concrete baked clay and fly ash brick, for example, is that we're actually sintering this product at 1100, 1200, 1300 degrees, and so we are creating a crystal matrix where that heavy metal isn't leaching out through physical contact, and we have done some testing on that we're certainly happy to share with investors and partners, and we've got a high degree of confidence in.